What do you mean it's not equal? What am I supposed to do with it if it's not equal? Calm down, we'll get to it. Let's review first. Remember that equations have equal signs. Today, later, we're going to look at things that don't have the equal signs. When we have an equal sign, we expect to have one answer, or as we're going to start calling them, solutions. For example, we've learned that if 2x plus 3 equals 7, we need to think about there being a wall here. We need to do the inverse operation of the constant, and then just start following along. So 2x would equal 4. Finish that with a division, and we learn that x equals 2. So here we have just one answer. X has to be 2. It can't be anything else. Or if I have a problem like this, remember that we need to use the distributive property, or if you're more comfortable, the box method, which I can show you. And then we're going to have negative 8x, and then negative times negative is a positive. Again, we can draw that wall if you're more comfortable. Again, do the inverse of the constant. Those are gone. So negative 8x is equal to negative 136. And then we're going to go ahead and divide both sides by negative 8. And I'll move over here. X would equal a positive 17. Again, there is only one answer. X has to be 17. But remember, you learned recently that sometimes an equation has no solutions. For example, again, I'm going to draw my wall. I'm going to go ahead and put both of my variable terms on the same side. So I will subtract 4x from both sides. And I know that when that happens, these are gone, those are gone. So what I'm left with is 5 equals 2. Well, 5 equals 2 is a false statement. So in this case, we learned that for this particular equation, there was no solution, no answer. We also learned recently that sometimes an equation has many or infinite solutions. And we do sometimes use a symbol for infinite. The symbol for infinite looks like a sideways 8. When we solve these, again, I've got a distributive property here. So I might have 3x plus 12 equals 6x plus 24. Draw my wall if you need it. Again, I need to get those variable terms on the same side. So I will subtract 6x from both sides. When this happens, I'm left with negative 3x plus 12 equals 24. And then when I subtract 12 from both sides, I get negative 3x equals 12, and I made a mistake on this one because it doesn't work. So in any case, where this was supposed to have an infinite number of solutions, it didn't work out that way. So we would find out that x is actually equal to negative 4. So this one does have one solution. If we were to have infinite solutions, we would end up with something like, for infinite solutions, we might see 12 equals 12, or 5 equals 5. It's something that would make a true statement. But because I wasn't paying attention, that didn't work so well here. I am going to go ahead and let you practice just a few of these before moving on. All right, time for some new learning. Let's take a look at the word inequality. First, I want to look at the idea of the in part. The word in means not. Okay? In the rest of the word, we also see the idea of equal. Well, we know that an equal sign, or the word equal, goes with our equal sign. So the word inequality means not equal. And those are the kinds of problems you're going to work with today. Since inequalities don't use an equal sign, we need to use a different kind of sign instead. So we would use things like this. We might use a greater than or a less than. We might have a greater than or equal to or a less than or equal to. You studied these in middle school, so we just need to kind of remember what they do and how they work. When we read these problems, we need to think in our head of what happens. So for example, in this question, this reads, x is greater than 4. This means that x could be 5, because 5 is greater than 4. X could be 7, because 7 is greater than 4. X can be any number I want as long as it's bigger than 4, and it makes that a true statement. On this page, this says that y is less than 3. Again, y has many answers. Y could be 2, because 2 is less than 3. Y could be -5, because -5 is less than 3. Y could be 0, because 0 is less than 3. So just remembering what you learned in middle school about inequalities. Our job today is to solve the inequalities. So solving an inequality can be just like solving an equation. For example, if I have 3x plus 2 is greater than 11, I'm going to treat that greater than sign like an equal sign. I'm going to go ahead and I'm going to draw that wall to keep them separate. I'm still going to think about moving that constant to the other side. So now I have 3x and 9. I still want to finish up with the division. So here I have x and 9. What I need to remember, though, is that originally I started with a greater than sign, and that's what I have to use for my answer. X can be greater than 9. Any number that I put in place of x will make a true statement as long as it's bigger than 9. Let's try another one. On this side, I want to do x divided by 5 plus 7 is less than 32. Again, pretend that you've got that wall here so that you can work. And then we want to subtract the constant. So now I have x divided by 5, and 32 minus 7 will give me 25. Just like before, because it's x divided by 5, I'm going to multiply by 5 on both sides and finish with x and 125. But because I started with this symbol, that's the symbol I need to use at the bottom. X is less than 125. As long as x is any number smaller than 125, we could put it in place of x. Now I'm going to have you practice a couple of these. There is one exception to the rule, and that has to do with multiplying or dividing by a negative. So, if I have negative 2x is greater than 14, I know that my job says I have to divide by negative 2 on both sides, which would tell me that x is greater than negative 7. Well, think about that. If x is greater than negative 7, then maybe x is positive 2. But if I take negative 2 times 2, that equals negative 4, which is not bigger than 14. So whenever I'm going to divide by a negative number, then I need to make a change. So I need to think about this. Because I divided by a negative, that means that when I bring this sign down, it's going to flip directions. Notice it's when I put the negative on the bottom, not the other way around. So if I wanted to try this again, and maybe I said this time that I have w over negative 2 divided by negative 2 is less than 4. And we know again that to solve this, I would multiply by negative 2. And so doing that would give me w in negative 8. But again, because I multiplied by a negative, that's going to take that sign and make it flip directions. Now you're going to practice for a little bit. Finally, remember, the steps to solving an inequality are the same as solving an equation. If your last step is to multiply the other side by a negative, flip the sign. If your last step is to divide by a negative number, flip the sign. One more thing. If I do this, it is different than if I do this. In this problem, I am dividing by a negative, which would mean for the answer, the sign changes. Over here, I'm dividing by a positive number, so the sign does not change because the denominator over here was positive.